Hello students, welcome to this lecture. So in this video we are going to see about the selection of processors for embedded systems. So in this video we are going to see about the how to select a processor for an embedded system, because selection of correct processor for an embedded system is based upon the nature of the embedded system. So, as we have classified the embedded systems into main three categories, like small embedded system, medium embedded system, and sophisticated or large embedded system. So, based upon the requirement of the embedded system, we need to select the processor. So, the selection of processor needs to take attention about some criteria. So we are going to discuss about those criteria in this particular video. So if we need the processor that have to be very faster in nature for a system which we need to design, that particular processor needs a higher clock speed and the higher throughput. So the higher throughput means we are here mentioning it as a MIPS rating. MIPS means a million instructions per second. So the amount of instruction that can be executed by a particular processor is called as MIPS. So that particular rating of a particular processor is going to decide what is the throughput of that particular processor. So this first thing have to be kept into mind. Second, if we need high computing performance of a system, so we can either choose a pipeline architectured processor or a superscalar architecture processor, depending upon your requirement, because for some of the applications we may have processing of some of the threads, so the number of threads have to be limited for pipeline processors, and if the number of processors are going to be somewhat higher, then we need to go for superscalar architectures. If we truly need a high performance or very high throughput processors, then we need to go for atomic processing units. So that these kind of things can be implemented using the prefetch caches and the register files also. So if you are using the register files, there we expecting a fast context switching between processors, because as we are going to design our embedded system as a hard real-time embedded system or soft real-time embedded system, depending upon the requirement, we are going to choose a particular processor. So if you are going to design an embedded system as a hard real-time embedded system, we need to have a fast context switching between the instructions or the processors. So for that we need to have some register windows also. So without them we cannot achieve those kind of capabilities. Next, for an embedded system, as we have seen in the previous videos, that we have to keep into mind the power consumption as a major constraint. So the power consumption have to be limited for an embedded system that can be taken care by a processor with unprogrammable auto shutdown capabilities. And if a processor having very good power management abilities to stop, to sleep, or to wait, or to hibernate itself for an ideal periods, then that particular processor is very good in its power consumption rating. So that power consumption rating is very much important for design of an embedded system. And if you go for the memory side for suitable memory and for the suitable processor, we need to have to access that particular memory in high speed. So in high speed means we need to work out that particular memory into a burst mode. So that kind of mode accessing have to be enabled by one processor. So that have to be taken care when we choosing a processor. That is, that processor should have capable to access our memory with the burst mode capabilities. So the next thing, if you are going to choose a processor, we need to check whether that particular processor having a required tool chain for processing. Because if you are writing a program for a processor, that processor have to process that particular program and it have to be converted into hex file. So that hexadecimal file, and that is the binary file, have to be put into that particular processor to run. So in order to do that, as we are very familiar with high-level languages like C, C++, Java, we need to convert those particular programs into a hex file, that is the binary files. So that is going to be executed by the processor. So as we go for the very higher-end processes, we need to check whether that particular tool chain, that is the compiler which one is going to compile the particular program in higher level into one machine language, and after converting into a machine language, we will be putting that particular machine language program into the assembler. So assembler will be converting that particular assembly language program into a binary code. So this assembler will be working in conjunction with this linker and locator in order to have the register files and the other registers to be located into that particular program. So these kind of programs will be used to locate that particular register files into the architecture of the processor. So these kind of tool chain are very unique for a given embedded system. So we need to look ahead that these kind of development tool chains are capable to be run with all the capabilities of all the data formats of a particular given system. So if a particular system is going to be integrated into another system, that system have to be incompatible with the embedded system which we are designing. So that kind of capabilities can be checked with whether that particular system is a little endian and big endian data formats. What does it means that what is little endian, big endian means? Little endian means if you are going to write on particular data, 16-bit data or 32-bit data, our memory chips will be only storing 8-bit data. So we need to segregate and we need to cut those 16-bit and 32-bit data as two parts or 4 parts respectively. So those 2 parts and the 4 parts have to be stored inside a memory. So that storage is, if the first location is going to be stored with the lower byte address and the second one is going to be stored in the higher byte address, means that's going to be called as little endian. So if the first address is going to be filled with the higher byte and the next bit will be filled with the lower byte, means then that is going to be big endian. So these data formats are very much important when we are interfacing two embedded systems with each other. So this kind of data formats have to be noted down very keenly while designing our embedded system and also while designing our development tool chains. So these kind of points are very important when we are selecting the processors. So here we have presented some case studies. Here we have 4 types of cases. One is chocolate vending machine. Another one is voice or data compression or video compression for a cruise control setting, and the third one is going to be network transceiver. The fourth one is going to be video processing. So by naturally these 4 systems are very much unique in their particular parts, because for chocolate vending machine we don't need any higher performance processors. So we may need very less amount of data length, and our processing is also going to be very simple, so that our chocolate vending machine is going to be simpler system when we are seeing in the view of real-time data processing. And whenever we are going for the data compression and the video compression type of systems, we need to have some of the good data length, that is 16-bit data length is required, and in that particular precision itself our particular processor should have some capabilities to run with the pipelining or superscalar processing. And if you are going for the network transceivers, that network transceivers are very high speed devices. So we need to have our processor to be high speed, and also that particular processing capability should be taking care of the protocols and the other transferring facilities of the network processors. So these kind of things have to be taken into account, and these kind of processors may need MAC units, because network processing and all needs some real-time signal processing applications. So those applications need to be taken care by the MAC processing units only. So we may need superscalar or MAC processing units. In some of the applications we may need atomic processor units too. And in the last case we need to have the video processing. So as you know, video processing and all are going to be signal processing applications, but video processing is a very high precise data processing. So we need to have that particular processor should be taking care that particular high precision also. So DSP processor is a mandatory one. So keeping these points into our mind, we are going to select our processor depending upon the criteria which are given here. So the required processor for first chocolate vending machine, it is going to be microcontroller. So for the voice acquisition, we need to have a microprocessor with 16 or 32-bit microprocessor that can be CISC or RISC type. So that is going to be coming under medium to high embedded system design. So the next one is going to be network transceiver. So for switching, since we need to have to deal with all the processing capabilities and the DSP processing unit also, and also we need to take care of the protocols which we are using, like IPv4, IPv6 or UDP or TCP/IP likewise. So there are many algorithms are available, so those algorithms have to be taken care. So for those algorithms, as we seen in the previous videos, we need to have single processors. So these DSP processors, general purpose processors, single processors are all going to be taken into a multiprocessor system. So that multiprocessor system is very much essential for these kind of network transceivers. for the video processing and the microprocessor plus DSP based multiprocessor systems. So here it is a mere multiprocessor system, GPP with single purpose processors. Here GPP with DSP processors are very much essential. So if you are going for the other the next processor selection unit is going to be the processor instruction. So cycles per second for microcontrollers it is somewhat higher, that is 0.5 second to 1 second. For microprocessor with the 32-bit it is going to be very much lower than this, so 0.01 to 0.04. And for these network transceivers and video processing it should be very less comparing to this also. So we will be having 0.005, that is 5 millisecond and 10 millisecond. So this is going to be the case of the multiprocessor systems. And for video processing that should come with the nanoseconds. So 100 nanosecond is very much essential for DSP processors. 10 nanosecond is a very least one. So we need to have that particular 100 nanosecond as a lower limit. So that is the limit for the processor instruction execution. So it is been here given as 100 nanoseconds. So the performance is as already we have discussed. And for chocolate vending machine we need to have only the CISC processors. Here CISC or RISC anything can be adapted, and for network transceiver and for the video processing it should be RISC in nature. And stack pointer, program counter and all that should be a 16-bit for chocolate vending machine, because for all the lower end microcontrollers will be coming with 8-bit data length and with 16-bit address length. So that is inevitable. So that will be the criteria for this particular chocolate vending machine. And for all the processing units we may have 32-bit, or if we are going for the other higher ends we may have 64 bits too, but here only 32-bit is enough, so we have stick on them. Next we will be going for the stack. So the stack whether it is needed with external or internal, since we have that particular capabilities are to be internal for the higher end processors, so for lower end processors they may be external in nature. Why? Because for the microcontrollers we may have the memory units to be installed in the system out of the microcontrollers. So we will be having that memories to be externally connected. So the stack and the stack pointers are going to be located in the external memory locations only. So here we will be having external for the chocolate vending machine, and for video compression and for the other data processing we will be having either as an internal or an external. So for the network processor and video processor should be internal. Why? Because these are all the very fast processing. So since these are all very fast processing, stack pointer should be inside the processor itself. So if it is not going to be, then the processor speed will be getting reduced. So in order to avoid that, stack pointers and other peripherals should be inside the processor itself. On-chip atomic unit. So for these two we don't need atomic units, since these are all higher processor. We may have atomic unit for them. Here for video processing we don't need any atomic unit, because for video processing DSP processor core is installed inside a multiprocessor system, so we don't need any atomic processor for this. Pipeline and superscalar will be very much essential for these three type of processings, because for pipeline processing are very much essential for the high speed and the high throughput devices. So these three are going to be the higher throughput required devices. So we will be having the pipeline and the superscalar architecture for these three systems. And on-chip RAM, off-chip RAM is externally we need to have. So here there is no need for the internal RAM, and here we need internal RAM. And on-chip register windows, since for this is a very small embedded system, we don't need any on-chip register windows, but for these three we need register windows, because if you are using a register window, we are expecting that we should have very fast context switching. So that very fast context switching should be used for higher end processing. So we need that kind of capability for these three processing. And memory management units and instruction caches are required for the higher end processors. As we know, for chocolate vending machine we don't need. And on-chip memory, we need to have this particular on-chip EEPROM. EEPROM is an electronically programmable ROM. So this electronically programmable ROMs need to be inside on chip for very lower end of devices only, because for very lower end of embedded systems only we may have very small amount of programs to be executed. So 14 KB is more than enough for a smaller embedded systems. So we will be using those for this particular chocolate vending machine, and for all the other cases we don't need any on-chip EEPROMs. And for external interrupts, the numbers are given. Since it is a multiprocessor system, for these systems only we need to have external interrupts as high as possible, because this is going to be a multiprocessor system. So we need to have as much as high possibly external interrupts we need. And floating point processing we don't need for chocolate vending machine, because it is on very lower end embedded system, so we don't need it for that particular embedded system. But for this particular network transceiver, since we are going to only processing binary data which are very less in precision, so we don't need any floating point processing. The first point. Second point is going to be, since we are going to process multiple amount of protocol stacks, we need to take into control. So those protocol stacks don't need any floating point operations. So we don't need those floating point operations for network processors. So this is a very important one. And the DMA controller, for DMA controllers we don't need DMA controllers, because we don't have much memory related, that is memory interface to microprocessor related applications. Since DMA is going to be a very high speed memory management technique, we don't need it for any of the processing. But for the network transceivers, since we need to processing those particular protocols and the other encryption and decryption processing, we need to frequently access memory. So we need to have that particular uninterrupted access of the memory. So for that only we need to have DMA controller. and we have given some of the examples, that is the selected processors for these kind of applications. Here 8051, 68HC, or 12 or 8196, and the PIC 16, F86, 84. And for this 8086 or 8860, and for network transceivers and all, we may use ARM7 or PowerPC, and for video processing and all, ARM9 or TMS families. Any type of DSP families can be used. Thank you.